Good morning, everyone. Thank you all very much for joining us today. My name is Dan Hayes. Hopefully you're all aware who I am. I lead the bus working group at the Zemo partnership. Hopefully you're all here today for the Hydrogen Zero Emission Bus Workshop in partnership with Wrightbus, Ballard and Metroline. Today, hopefully we're going to give you a quick whip through what it means to roll out hydrogen buses, some technical aspects, some of the operational aspects. We're going to give you a bit of background on policy as well. And then we're going to break up into groups and go and visit some of the infrastructure. We're going to have two buses out the back, one of which will take the first group out to the site down the road, take about an hour, and then they'll bring that group back, and then the second group will go off. So lunch will be served from about 12:30. Do let us know if you've got any challenges about getting away, and maybe we can get you on one of the earlier journeys. You should all have a little badge on. I'll touch a little dot on your badge, which breaks you down into groups. But I know some of you are here with friends, so you might want to go together. So we'll negotiate that at the end. I'm going to jump straight in. We don't have much time. We've got a lot of speakers. So who are Zemo? Zemo partnership are a public-private partnership between government and industry. We get grant funding from industry as well as our membership. We bring stakeholders together from across the road transport network, and we're more and more integrating with energy and with various other technologies to help transition to a net zero transport system. We have a wide range of different stakeholders, you can see, including fleet operators, manufacturers, technology providers, government bodies, environmental NGOs as well. We do most of our work through our working groups, so this is a bus working group event. We've also got commercial vehicles, passenger cars, fuels, and the energy infrastructure working group, which is looking dedicated at sort of the integration of vehicles with the energy system. Just to set you off, this is the state of the bus industry in the UK at the moment. Roughly 2,000 to 3,000 vehicles a year are typically registered. However, the last few years, there has been a bit of a decline. The UK bus industry is leading the charge to zero emission. In 2021, 55% of registrations were zero emission. However, there is still major uncertainty coming out of COVID around passenger numbers and passenger journeys and incomes, and that obviously presents a challenging environment for operators moving forward into the zero emission transition. In terms of hydrogen bus fleets, we're starting to get a good number of fleets across the UK. We've obviously got those up in Aberdeen, we've got the ones here in London and those in Birmingham, and we've got a good plethora of fleets coming on board. 66 in total are in operation today. We've got another 230 funded or planned. So we will have a decent number in the next few years of hydrogen buses on the road. There are also major hydrogen infrastructure plans. Obviously, we've had the hydrogen strategy from government, as well as the Scottish Hydrogen Action Plan, both of which are looking to deploy 5 gigawatts of hydrogen production capacity by 2030. So there's a big ramp up in the next few years in terms of hydrogen capacity. Big hubs are going to be Teesside, Humberside, Merseyside, obviously where there's big chemicals plants, and there's already a big push to reduce the carbon intensity there. And there are also some interesting projects such as the Dolphin project up in Scotland, where they're deploying electrolyzers on wind turbines to produce hydrogen at sea. So I'm quite interested to see how that goes. In terms of bus operations, it seems like there is an emerging trend that there's going to be a centralized production of hydrogen, and then that hydrogen is then tankered to the fleet operators wherever they are. So rather than having decentralized small amounts of hydrogen production, it's going to be produced in large amounts and then shipped to where the depots are and the refueling stations are. Government funding is very much driving the transition towards zero emission. We've got almost 3,000 zero emission buses outside of London which are either in service or have been funded. There is more funding to come next year. There's 205 million that DfT have yet to allocate for England. We've got another almost 60 million in Scotland to come as well for the next 3 years. And there are other funding pots which local authorities in particular are looking to use to support zero emission bus deployments. That includes the City Regional Sustainable Transport Settlements, you've got the Levelling Up Fund, you've got the bus service improvement plans and more. So local authorities are very much looking at buses and how they can support the transition to zero emission. In terms of some of the work that we do, and it's probably relevant to you recently, DFT announced the Zero Emission Bus uplift. So zero emission buses in England can now get 22 pence per kilometre. A crucial part of that will be getting a zero emission bus certificate. So if you're a manufacturer and you want an operator to claim, you'll need to get a certificate, and that includes testing your vehicle. We publish the certificates up on the website. The page is live now, so if you're interested to see who's got their certificate already, and if you're interested in testing, please do come and speak to us. Another relevant activity that Zemo are working on is the Renewable Fuels Assurance Scheme. And this is a scheme that basically enables operators to understand where they are getting their low carbon fuel from, and it gives you real granularity as to exactly the greenhouse gas emissions you will get from the fuel supply that you purchase from. So rather than just using an RTFO average, you'll be getting the exact greenhouse gas emissions for your specific fuel. So we've already started to certify various biofuel suppliers on there, and hopefully we should have some hydrogen suppliers on there in the near future as well. Just in terms of upcoming activity, we've got a couple of webinars next week with the EV Energy Task Force as part of Green Infrastructure Week. We've got our bus working group meeting for Q2 next week at Millbrook. It's going to be a physical in-person event. We've also got a commercial vehicle working group coming up. There's the ITT Hub in May. We will hopefully be hosting more of these zero emission bus workshops. We're looking at Manchester, Newport, Birmingham, and more. And hopefully we'll be doing some truck and van ones as well this year. So without further ado, there's just some added information about the funding pots there. But that's my conclusion. We'll be taking questions as part of the Q&A session at the end of the presentations. So I'd like to pass over to Prabs, who's going to give us an update from DFT.
Thanks, Dan.
Thank you.
Cool. Morning, everyone. So, as Dan said, my name's Prabjit and I'm from DFT, and I'm just going to give you a quick run through on hydrogen policy and some updates on our recent announcements. So, so Dan mentioned that we had this ambition for 5 gigawatts. I don't know if anyone noticed, but in the recently published energy security strategy, this ambition was doubled to 10 gigawatts by 2030. The hydrogen strategy itself sets out how we'll, reach that plan, but the ambition itself has been doubled since, the recent troubles. I'm sure you're all aware that I don't need to go over the first bullet point on how, important hydrogen is, but I think the important point to take is that government is technology neutral when we're taking this. It's the outcome of zero emissions is what our ultimate aim is. Battery electric or hydrogen, we aren't going to take a sort of view on what's appropriate from a central government perspective. More on hydrogen, I guess, in terms of our support is the RTFO. That's probably the longest running thing in terms of hydrogen support. I'm sure many of you will know that as a development fuel, it gets more certificates than any other sort of renewable fuel through the RTFO. And then another one that people might not have noticed from the energy security strategy is that we've also committed to set up a certification scheme. I'm sure there'll be probably discussions with Zemo on how that will interact with RFAS, but that was obviously another new announcement in the energy security strategy. That last bullet point is, again, just something that people may not have picked up, but we are committed to run annual allocation rounds for electrolytic hydrogen. So again, you can see our government is doing a lot to encourage the growth of the hydrogen economy in the UK. Specifically on buses, the 20 hydrogen buses that are running around London were part funded by the Low Emission Bus Scheme. The 20 in Birmingham were also part funded by the Low Emission Bus Scheme. And the 20 that Dan mentioned in Crawley were part funded by the Ultra Low Emission Bus Scheme. So, as I said, previous government funding schemes have supported hydrogen buses with that technology neutral caveat. It would be, remiss of me to not mention that the JIVE, the EU funding, also helped with those projects as well. I think Dan mentioned the West Midlands hydrogen in his previous talk, and I think it's very exciting, obviously, because it'll be the largest hydrogen bus fleet in the UK. But that was part of an announcement on the 26th of March where we announced almost 1,000 zero-emission buses with nearly £200 million of funding. You can see some of more of the detail on the screen there, but again, that just sort of reiterates government's commitment to decarbonising the bus fleet, as we said in the National Bus Strategy and the Transport Decarbonisation Plan. Again, just mentioning another thing that Dan spoke about, which is the BSOG Zero Emission Bus Incentive. As Dan said, this was announced on Friday, the 1st of April. So I'm sure many of you will be aware that under the old low carbon emission bus incentive, zero emission buses were only eligible to claim 6p per kilometre under BSOG. Through this, they'll now be able to claim 22p per kilometre. This is ahead of a broader reform of BSOG, which again we committed to in the National Bus Strategy and which is reaffirmed in the Transport Decarbonisation Plan. I think a good thing to pull out of the NBS is that, or the National Bus Strategy, is that we call the existing BSOG regime a fossil fuel subsidy. So it sort of gives you a direction of travel in terms of what we want BSOG to achieve going forward is achieving both environmental aims along with increasing patronage and reducing fares. One thing to pull out from this new BSOG announcement is that unlike the LSEB, this will include vehicles which are under 22 passengers/seats, so minibuses which are zero emission will be able to claim the BSOG ZEB incentive. Bit more on this and specifically on hydrogen. I think being pragmatic and recognising the current status of the hydrogen economy, we are not going to be asking for through the RFAS, for example, certification on green or blue or any sort of colour of hydrogen. We're being pragmatic. This is purely for a temporary uplift. The broader reform of BSOG will obviously take a view on how the provenance of any sort of hydrogen used, but at the moment we're being pragmatic and allowing any source of hydrogen. Again, Dan mentioned this, but along with Zemo, we've developed a zero-emission bus definition. I'm sure you're all familiar with it. Basically ramping up from ULEB, so instead of 30%, 50%, but this important thing of having no internal combustion engine, so no hydrogen combustion, no diesel heaters, are key things to remember. Something we're doing with Zemo. So this is the Zero Emission Vehicle Repower Accreditation Scheme. So part of that BSOG uplift, we committed that repowered vehicles would be able to access it if they can get a ZEB certificate. The route for them to get a ZEB certificate would be through going through this ZEVRAS scheme. So Zemo are currently convening a working group and looking to put forward proposals and hopefully have something in place in due course. Just a final update from us. So alongside that funding that we announced on the 26th of March, we also announced some policy proposals on ending the sale of new non-zero emission buses. So again, this was something that was committed to in the National Bus Strategy. We ran a light touch consultation last year. Everyone's sort of input into that helped shape our proposals. So we're now seeking information on a specific date between 2025 and 2032. Key thing I would take away from this is that this would apply to Class 1 and 2, M2 and M3 vehicles, for those of you who like your type approval. We're also taking a question on whether that is an appropriate method to regulate, but it does slot in with the existing car and van and HGV phase-outs. This consultation closes on the 21st of May. If anyone has any questions about it, I would encourage them to get in contact with the department. There's an inbox, buses@dft.gov.uk, so please just give us an email. But yeah, we'd be happy to chat through any of the things that we've discussed today. But I think that's it from me. Yeah. Thank you.
Thank you very much, Prebz. I'd like to pass straight over to Tom. Just to the right.
Good morning, all. Firstly, many thanks to Ian for allowing us to come here today and for Dan and the team at Zemo for organising. My name is Tom Greenshields. I'm the Head of Business Development for Wrightbus. Wrightbus as a business has been operating for 75 years and can genuinely be said to be a leading innovator within technologies within the sector. The first battery electric EV built in the 1990s. Transitioned to our own body. So Wrightbus products are wholly and utterly made in Northern Ireland. The first single deck hydrogen fuel cell EV in 2008 in London. The iconic Routemaster that we see today. And the first hydrogen fuel cell double deck vehicle in 2016. An interesting point about production in the sense of last year, 2021, we were 70% low emission Euro 6 diesel vehicles. 22, we are 70% zero emission, the majority of that being EV, although we are pushing as hard as we can to have a mixed fleet across that. Just to touch back on the first hydrogen fuel cell vehicle, 2008, 8 single decks, 12 years of service. I can run through the stats, but at the end of the day, they were very successful, which gave us the kind of launch pad to move on to the next product, which becomes the Hydroliner. The figures tie up with yours, Dan, in the sense that this is what will be operating this year for the Wrightbus Hydroliner within the UK. Just to touch a little bit on the vehicle itself, I'm gonna, as a manufacturer, I'm always going to throw in another product next to it because we can get away with that with agnostic. But it's very simple in the sense that There are 6 hydrogen tanks at the back of the vehicle, as you'll see here, 27 kilograms of hydrogen at 350 bar, getting a range of circa 280 miles, an 85 kilowatt fuel cell, the battery system. It's a very simple, straightforward product. I can't move from there, can I? The Hydroliner, which is effectively the same vehicle on the other side, has the battery packs in the deck to try and maximise passenger capacity. And currently you're working on 2 battery packs there at 340 and 454 at 150 and 200 miles. That bus is on demonstration throughout the UK at the moment. We're running telematics on it all the time. What we're very keen for people to do is use it and keep using it so that we can verify the data that we have on the field to make sure we're getting the ranges that we think we are. At the end of the day, the engineering team are very confident, but it has to be operated in temperature and loading and everything to get the truth of the matter, and we will publish those stats. And there's a commonality of systems across the buses. These are buses that are built to be electric buses and hydrogen buses. It's not a diesel bus that's been altered, and that's very important as we progress into the next set of products, which are, again, will be available this year. Our single deck hydrogen and electric buses effectively have highly efficient and quiet electric tractors. It's commonality of parts between the 2 kilowatt motor, the inverter. It's the voice system in both buses. So the next gen fuel cell on the hydrogen bus, 70 and 100 kilowatt. And then you get to the different sets of tanks on the roof, 32 kilograms at 400 miles and 480 kg at 810 miles. That product will be operating towards the end of this year. And then there are 3 sets of options on battery packs on the single deck buses, getting from 150 to 300 miles. I quite like this slide actually. This is the... I mean, you'll all be aware of the fact there is a synergy between Wrightbus as a manufacturer and the owners of the business being from the Bamford family and therefore the JCB group. It was not a mistake in the fact that the business was taken out of administration on the basis of the fact that, as you can see on this slide, you have a very comfortable point where there is construction equipment. And it's particularly important in construction equipment because of the weight differential between a machine and how it has to tear things out of the ground. The more weight you add into it, the more power you need. So, i.e. battery packs and more battery packs and more battery packs in the back of an excavator makes a very big excavator for a very small hole. So the simple fact about it is that was the interest aspect and how Wrightbus had managed to get an 18-ton bus moving and what the future holds for hydrogen. When you've got high, daily hours of operation and a high energy demand, then you've got a question as to where does hydrogen sit within the EV side. We are very much of the opinion that we come into heavy capital equipment where it's an onerous route where you have limited charging, then hydrogen very much is the answer. If you're on a refrigerated, seafood from Aberdeen to London for the restaurants in the morning, you can't be stopping and charging that every 2. It doesn't work. So we have to find a way of fuel cell technology. I think we talked. There was a mention of hydrogen combustion engines just there, which is also what other people are looking at. The one side of hydrogen combustion, as the DFT have rightly said, it does emit. Yeah, you're still getting a NOx off-take from that. So you've got rid of the particulate matter, but it's not a zero emission product. Very simple fact, and we are very agnostic as a manufacturer in the sense of the product that we put out there. The most important thing is that people look at what's available, analyse the information. Everybody knows their routes, they understand their passenger loading, and the product in essence will work itself out. Battery electric vehicles are more efficient and less energy demanding, but they're limited in range. Fuel cell vessels are not as efficient, but they have far better range. And that can only improve, What we do as a business, and we have a great history with Queen's University in Belfast. We run a diagnostic tools, a route planning tool that has been built up over those 25 years. It's completely linear. There is no input from the manufacturer. It looks at the bus, the routes, the loading, the topography. You can change the temperature, you can change the amount of people in it. You can run across whatever routes you have, and effectively it will tell you what the end technology is, whether that be diesel, whether that be hydrogen, whether that be EV, whether it be a 3-string EVI, mobile, or a 4-string. It allows you to then look at the routes within your area and decide what the best technology is for that without actually thinking, well, the battery man's telling me this or the hydrogen man's telling me that. But actually, it should be a simple decision based on the output that is required and the route in itself. Everybody, I was at COP this year for 2 weeks, and I got more questions about, safety than anything else on the bus, because people who are not in the industry, I just open the back and see hydrogen tanks and instantly think of, but there are very simple key safety, and hopefully when we go out today, Ian will touch on it. These buses are incredibly safe, and it's a very simple way to move them into a depot if you understand what you're doing. So, in summary, much than anything else, there is a step change in fuel cells. They're becoming more efficient. The cost of tanks is coming down, as are the drive lines. As has just been commented on, the scaling up production of H2 is happening across the country. The fuel cells are becoming more efficient. We as a business are getting better, having now come down 2, 3, 4, 5 years of this, of getting efficiency out of the fuel cell and getting the bus to do what it's meant to do. Also get a use of the heat generated to run the bus. Hydrogen is definitely in the bus market. We can see fuel cell buses operating, and they're operating very well. So we're now getting to the point of what's coming next. And we as a business, as I said, completely agnostic in the sense of what products we do. It should be the route that dictates what the product is. But given what's happening in the world at the moment, certainly our energy security is very important. Hydrogen is very much a part of that. And these buses are operating today. If you require any further information, we will be here for the day, and more than happy to talk about it, and looking forward to the visit with Ian today. Thank you very much. Right side.
Right side there.
Right side.
Okay. Good morning, everyone. I'm Ben Worth. I'm the Managing Director of Fuse Finance Limited. Thanks for that, Tom. Fuse is a lease and asset management company. We're part of Joe Bamford's group of businesses, which includes Wrightbus, who Tom spoke about previously, and Rise Hydrogen. We're privately owned by Joe. We're a zero emission specific asset finance and asset management business, and given the complexity of the different stakeholders required for decarbonisation, we've formulated a SPV funding model which accommodates all the different stakeholders required to achieve zero emissions. This enables us to meet with operators and provide a level of service where we look at depot upgrades, the charging and fueling requirements, the buses themselves, be that battery electric or hydrogen, and additionally look at R&M packages or parts assurance agreements as well. So Fuse really is to sit there and try and make what is quite a complicated process as simple as possible for the end user, the operator. And Tom's already alluded to the TCO model that we've developed. Quite simply, we sit there with the operator and using the route planning system, identify the optimum vehicle for the required services. That enables us to identify the infrastructure requirements, be hydrogen again or battery electric charging facilities. That gives us the fuel and power indicative costs and also the maintenance costs. And we then can sit with you, the operator, and give you a detailed TCO calculation. At the moment, given even with the changes in cost of fuel, given that also diesel has increased, we can confidently give you below parity with battery electric at the moment to diesel, and we can also now meet parity with hydrogen and diesel. The real challenge within Wrightbus is to get the capex point on day one down on the hydrogen product, so we can then get hydrogen with parity with electric. And I think as things start to scale up, as Tom alluded to, that capex point will start to reduce, and we will very quickly be at parity with battery electric. Once we've identified through the TCO the optimum vehicle, we then can sit there and try and distill that down into a single monthly payment for the operator. And as I said, that can be for all these parts, infrastructure and vehicles, or in the case of battery electric vehicles where infrastructure may be in place already, we can just look at providing funding just for the vehicle itself. But we can offer it across the entire ecosystem. And additionally, what is slightly unique, I think, with Fuse is where the traditional sort of model would be for the OEM to sell a vehicle with a limited sort of 3 or 5 year warranty on, we want to be involved with the operator for the duration of the lease agreement. So that's a 5 to 21 year period. And we do that by offering an asset management service for the duration of that agreement. Now this might be out of sync, so bear with me. I might have got too clever. Oh no, it's not bad actually. So with regards to the offering asset management, we do this by tapping in and using the Uptime 365 predictive telematics system. That enables us to monitor the vehicles on a daily basis. It's a predictive system, so we will be ingratiating ourselves with the operators from day one to allow you to manage your fleet on a predictive nature of failure, as opposed to waiting for something to fall over in service. This enables us to also ensure that the vehicles are being operated in accordance with all warranty and service requirements, and to also make sure that vehicles are being charged correctly, being fueled correctly, and operating as efficiently as possible from an energy point of view. And with regards to the asset management piece, that, as I said, that's for the duration of the agreement. We sit and have and hold the lease and asset records. We ask and we'll make sure that all the maintenance records are uploaded to the system. Again, this is to ensure that what is a very complicated bit of kit adheres to any warranty claims for the point you want to put warranty claims through. And annual inspections are also carried out on the vehicles. There are many different options on the asset management, and if we want to ask any further information on that, I suggest we do that offline, a one-to-one basis. We also do R&M contracts as well, or as I said, parts assurance agreements. I'm going to try and keep this as short as possible. So, in conclusion, it's a turnkey solution, a term I keep hearing in many of the presentations that I go to, such as this. We are able to offer a turnkey solution on battery electric and also on hydrogen. Fuse are there to act as the lease and asset manager. We also act as the conduit between the PTA and PTOs and the various stakeholders if required. And we also act as the conduit, again, between the PTA and PTOs where funding is involved. So, for example, we're about to announce our first successful SPV funding model with Milton Keynes. And we've been ingratiated with all the various stakeholders, again, across the whole ecosystem. The key to it is, as I said, is we sit and offer a TCO calculation so the operator is comfortable that they can see for the duration of that lease period, that they understand where we think the costs are going to be for them. And that is all quite simply distilled, as I said, down into a single monthly payment. And I think that's as quick as I've ever gone. So, yeah, if you have any questions, go now, or I don't know the procedures. Excellent. Thank you.
Thank you, Ben. So yeah, we've heard about the vehicles, and now we're going to hear a bit more about the technology from David from Ballard, just to the right.
Yeah.
Okay, thank you. It's good to see you all. So my name's David York. I'm Ballard Power Systems Europe. I've worked for Ballard for about 2 years now. But before that, I actually was working for Tower Transit, the operator in London, and I oversaw the operation of the fuel cell buses in London. So the 8 buses that Tom showed on his one photo, I oversaw that. So I've got a bit of operational experience and now work for Ballard themselves. So I guess that means I believe in the technology as I'm still in it. So about Ballard, possibly a few of you haven't heard of Ballard, quite a few of you probably have, but Ballard's been in business over 40 years, about 42 years now. There's over 1,000 employees worldwide. The main headquarters is based in just outside Vancouver in Canada. I work for Ballard Power Systems Europe, which is based in Denmark. And recently, in November last year, we acquired Arcola Energy, who's now been renamed Ballard Motive Solutions. And so now we have quite a large presence in the UK. So just to give you sort of some rough idea, we've seen the numbers in the UK of buses, but there's a lot of fuel cell buses operating around the world. Ballard have powered over 1,300 fuel cell electric buses. So it's not, Ballard's been around 42 years. There's a lot of buses out there. It's not a new technology which often comes up. So it's fair to say that zero emission transport is electric vehicles. I think we can all agree with that. And a fuel cell vehicle is an electric vehicle. That's important to note. The difference is that with a battery electric vehicle, we're plugging in the wall and we're getting our energy from the grid or the wherever, from the wall. We unplug and we have a range and we run that for the day. With a fuel cell vehicle, we're actually making the electricity on board. So as long as we've got hydrogen in our tanks, we can create electricity and we can drive around. So some of the architecture Tom went through earlier, but very simply on this picture, you see the fuel cell bus. You've got battery, electric motor. You've got some controlling electronics engineering. We've got hydrogen going in. We've got oxygen from air going in into the fuel cell, creating electricity, charging the battery, because all the buses, all electric buses are a hybrid technology, and that's important to note. So with a diesel hybrid vehicle, we've got a diesel engine, a generator that's charging the batteries. If you take that away, plug it in the wall, we've got a battery electric vehicle. Obviously the battery size changes and that, but if we take that away and put a fuel cell there, we've got a fuel cell electric vehicle. So the fundamental architecture of these low and zero emission buses is actually very similar. So again, I can't reiterate that a fuel cell bus is an electric bus, and I quite like this slide because it kind of shows the difference on where we are. So with a battery electric bus, we've got potentially low initial infrastructure costs. There can be issues getting enough power into the depot. I can see Ian's grinning, so I'm not sure. We've got low maintenance costs, and we got high powertrain efficiency you often hear about. But we often have a bit of a range issue and that. So with both vehicles, a fuel cell and a battery electric, we've got zero emissions, we've got good efficiency, we've got an electric drive, and we've got low noise. But with a fuel cell vehicle, the infrastructure costs reduce as we scale up proportionately. We've got a fast fueling time, and that's incredibly important for a bus operation. We don't have any reduction of passenger capacity. We've got a longer range, so a fuel cell vehicle can be a direct replacement for a diesel vehicle, so it can be a drop-in replacement. And not so much in the UK, but elsewhere, there's more tolerance for extreme weather conditions. So for some of you, I'm sorry if people know this, but I just thought I'd just basically run into what is a fuel cell, because the word is bandied around a lot. So a fuel cell, very simply, and my sort of very simple explanation, you've got hydrogen that you've got stored in your tanks. We need oxygen that's in the air, so we take oxygen. And then in the fuel cell, we've got the proton exchange membrane. What that basically does, you've got the oxygen on one side, you've got the hydrogen coming in, it takes the proton from the hydrogen and lets that through, but not the electron. So then we use that electron to power the bus, because it wants to now join back up with its proton in kind of simple terms, and then joins with the oxygen atom, so we get water, H2O. So our only emission is pure water. So in theory, the process is quite simple. And what you see there is one fuel cell. What we what we actually have in the bus is lots of those put together, and what we call a fuel cell stack, to get the power that we need. Sorry, excuse me. Then we take that fuel cell stack and we put that into what we call a module. So the module has all the balance of plant to get the hydrogen going into the stack at the right rate, to get the oxygen going into the stack, or the air going through the stack at the right rate. We got coolant in there and other things to get all that going. So what you end up with is a fuel cell module, and this is our FC Move platform, just an example of what it looks like, fairly literally a black box. So and with this is our 100 kilowatt version, where we've got a rooftop version, which is the long flat one, and now we're developing an engine bay version. So that is basically what a fuel cell is. It's quite simple kind of to explain on paper, but all we're doing is producing electricity to run an electric bus. And I think that's a good way to think about it. So the advantages, as I've already touched on before, is to sort of maintain speed, and we can use demanding routes. We're not so worried about topology and speeds and things like that. The range is good, so we got flexibility, and in a bus environment where you've got a whole depot full of buses, one of the issues with battery electric buses, you might be route bound for one particular type of bus, where a fuel cell bus you could have the flexibility like you do with a diesel bus to put them on different routes. Hydrogen has a high energy density, but also what's very important is we've got quick fueling, so we can fuel in a matter of minutes as opposed to a battery electric bus, which can take a number of hours. The beauty of this from an operational point of view is that we can keep the same operational procedure and process as we do with a diesel bus. So the bus goes out all day, comes back, fueled, washed, parked, ready to go out again the next day. And I've always said, especially when I was operating the buses, actually a bus's job is to move people from A to B. That's what we're trying to do. We don't really care too much about what the driveline is on there, because if you're waiting at a bus stop, you want your bus to come along. You don't really care. Certainly in London, people don't care what comes along. They're going to get on the next bus. And so really, the more boring you can make the bus and it just does the job, actually, that's the more successful you are. And the fact you're doing it zero emissions is great. So just a little bit word on pricing and some of where we've come from. So this graph sort of shows some of the projects that's happened around Europe. So the buses that Tom showed on the picture, the single deck, were brought in as part of the Chic project. So that was a European funded project, from the Fuel Cell and Hydrogen Joint Undertaking. And London ran 8 of those buses. And then as projects have come on, so we've had high velocity, high transit, the cost of the bus has come down. And then London was also involved in the 3 in Motion project. So the 3 in Motion project, there was 2 extra buses were brought in, so the fleet went from 8 to 10 buses that ran. And then we've moved on now to here, the sort of Jive project, which is what we're involved with in London, and the price is continuing to fall. So the further we go on, the cheaper the buses will get, and along with that, as Ben said, with the TCO, etc. So just to sort of finish up, I've got a couple of extra points. You'll see that Ballard's tagline now is "Here for Life," and we're very much about that. So we've got an after sales service when we're working with an OEM such as Wrightbus. We have application support that we can help. We now have the BMS offering where we can do further work with the integration of the buses. But we know that it's very important on running buses that you give the whole the whole life of the bus. That's important, and that's what we strive to do. We have 2 technicians based in the UK for servicing buses, and as fleets grow, I'm sure that will grow. And then just a final slide, just to talk about sustainability. We're very, very aware of sustainability. It's a bigger subject now, and fuel cells fall very, very well into the sustainability model. Ballard are committed to being carbon neutral by 2030. But what's important to note is that the fuel cell can be refurbished when it gets to the end of its life. So we can refurbish, we can recycle most of the platinum that's in there, we can reuse our plates, rebuild the stack, so you've got a sustainable product that you can continue on with. So that's a very important factor, and I think the sustainability is going to become a bigger issue moving on. So that was all I wanted to say for today. I'm around for the rest of the day, like all the other speakers, and happy to talk with someone. I think we're taking questions later, but I'll be around all day, and it's good to see you all. Okay, thank you.
Thank you very much, David. Good to finish on some life cycle referencing. It's something that Zemo will hopefully be picking up in the future. On to the juicy stuff. Invite Ian Foster up to speak. Thank you very much.
Just to the right, yeah.
Morning, everyone. Thank you for coming. You've heard the propaganda and the the dream. I will take you through the bits now we get from the coalface. Yeah. Okay. I'm not going to read the slides off. You can read the slides, and I'll just comment on some of the sections. So, I'm Group Engineering Director for Comfort Delgado businesses in the UK. So that's England, Scotland, Wales and Ireland, not Northern Ireland. Comfort Delgado is one of the world's biggest transport companies, biggest transport operator in Singapore, biggest private transport operator in Australia, and we have businesses in China and Vietnam. So we operate about 40,000 vehicles across the world. In London, we operate about 16% of the fleet. You can kind of see from the makeup of our fleet at the moment, we like to think of ourselves as a first user. So when a new technology comes to the market, we are generally at the forefront of introducing that into London and operating it. So we're the guinea pigs generally. As you see, I've got 720 hybrid buses, 91 EVs, 20 H2. We've actually got 22 hydrogen vehicles. We've got 2 van hauls which we've taken on for TfL, and we've got 88 electric buses just about to be ordered. 6.5 million zero emission miles in the last 3.5 years. So probably 2018, Martin? 2018, 2019. 2019, we're in discussions with TfL about becoming the preferred operator for operating 30 hydrogen buses, which subsequently was reduced down to 20 because of funding issues. And within that, there was the decision to be made on what type of hydrogen we were going to use, where the hydrogen was going to come from, and from that, we decided not to produce hydrogen on site, as they do in Aberdeen. We've been up to Aberdeen and looked at the operation up there. We decided that we were going to tank the hydrogen in because there was a redundant wind farm in Kent, which Rise were going to take on, and they were going to produce hydrogen from there. And then it would be tankered into us at Perivale down the road, which you'll see later on. And we're still, even though we're not using the power station, the hydrogen production plant using the wind power, the station is still set up as it would have been for that. So as that comes online, the tankers will be replaced by tankers which are bringing in hydrogen from wind farm. In terms of the site, when you get down there, this is where the practicalities of transport do not tie up with the expectations of salespersons and developers who think that everyone's got a square or oblong garage where you can put everything it fits in perfectly. This is a prime example. When you get to this site, it's shaped like a wedge of cake. So it's really big at the front, and it just gets smaller and smaller and smaller, goes down the bottom. So within our considerations of EV or hydrogen, We're a first user of EV. We understand how much space we lose for electric vehicle infrastructure and charging equipment. And when you get to Perivale, you'll see the space that has been utilised for the hydrogen fueling station used to be our staff snooker room and our blind store. So with a bit of ingenuity in terms of the design, we've managed to squeeze that piece of kit into our depot and lost no parking spaces at all. Whereas, say, my Holloway bus garage, where I operate 60 electric vehicles from, we've lost, putting 60 vehicles into 230 vehicle garage, we've lost about 5% of the space just for 60 vehicles. So you can kind of work that backwards about how much space you lose when I try and put 250 vehicles or 230 vehicles worth of power in there. I'm going to put power in there and I'm going to be left with 180 vehicles. So it's a really pertinent point for hydrogen, is it can be utilised in a way which doesn't affect the overall parking capacity of the depot. So the reasons Perivale was chosen, well, let's go for the first thing. The route itself, it's a 24-hour route. So David's already pointed on the fact that you can fill a hydrogen bus very quickly. And for us, that means vehicle's used, it's brought back in, it's refuelled, it's washed, it's cleaned inside, any defects during that duty are dealt with, and it's sent back out in service straight away. So that takes about 25 minutes. Our electric vehicles will come in. A night bus, I probably have to bring it in at 3 o'clock in the afternoon to charge it up sufficiently for it to go out again at 7 o'clock or 6:30 at night, and that won't get me through the full night. Inevitably, I have another bus which I have to send out to swap over that about 2 o'clock in the morning, because you never get the full charge in them. So it's a real operational issue for us, and anybody that's spoken to me will hear me spouting off about it all the time, because there is a technology which is EV solely, which is good from our work. It's good for 70 to 100 miles continuously, providing you get the charging cycle right. Hydrogen, we can duplicate the current ICE mileage and systems and schedules that we put in, so it's minimal interruption to our business process. So the reason that Perivale was chosen was the Route 7, the primary route. It runs from Perivale, it runs into the centre of London, it goes through Holland Park, it goes through Marble Arch, it goes through very high profile areas, very high pollution levels as well. So it's a high priority route, it's a 24-hour route, and it's an intense route. So it gave us TfLs getting a bigger bang for their buck in terms of everybody sees it. It's in those very visible areas. And for us, it has an instant impact on the pollution in the area that route runs through. Our specification for the site was, we didn't want it in a big housing estate because it would have caused more problems with the planning for Ealing. So Ealing, the Perivale site sits on the edge of the A40, fairly industrialised area, and the nearest housing is 200 or 300 yards away. So it's kind of ideal. Open air depot, none of the vehicles are parked underneath, so it reduces the risk for our insurers. And then we created space for a 2 delivery fuel pump station. And 2 delivery fuel pump stations there for 2 reasons. One is there's a certain amount of redundancy built in, so if one packs up, the other one can be utilised. But secondly, it allows us to fill 2 vehicles at the same time, which means the run-in is faster, and it stops any tailbacks and transport issues with the council because the vehicle's not going back out on the road. So it's very similar to the diesel cycle. Yeah, and for the other thing, which is really quite important for EV and hydrogen, is that the fact, if you don't own the land, the cost of bringing the electricity in for EV or hydrogen, the siting of the substation, the fact that the grid operator wants a 99-year lease and you've got a 5-year lease on the land, doesn't make for easy contracting with anyone. So we chose Perivale because I'd recently renewed the lease for a 20-year lease, which then made it easier for us to get the landlord to agree to us siting the substation on there, which now we're going to go back to because we need to increase it for the next tenders that are coming through. Yeah, and the route, again, where the EV would be challenging for the route, because it's a 24-hour route, so it's intense, and we wanted to get as much data out of the vehicle and as much use as possible. Current performance. So I'm not going to lie to you. There was a lot of teething problems with the vehicles when they first arrived. It's mainly sensors and switches, but in terms of the fast fill, this is a refrigerated hydrogen fueling station. So a normal hydrogen station, 15 to 20 minutes to fuel. The target of this station is 5, and we're currently operating about 9. So the hydrogen is refrigerated at the point of delivery, because as it passes through the nozzle into the vehicle, there's a temperature rise, and you have that safety issue of possible ignition, so it's super cooled. First issue we had, real issue, in terms of the fueling speed, was the fact that the valves on the tanks were not opening fully, and it was causing an increase in temperature, which the safety system was then shutting the fueling down. So there's an infrared communications between the vehicle and the fueling station. That was rectified. Took a couple of attempts. Sometimes some of the valves were leaking when they were changed, but Wright's got there in the end. The biggest issue we've had, and those that are in the business with us will already know what that is that the subframe assemblies which were holding the hydrogen tanks started to crack and come adrift due to the resonance from the driveline, wasn't it? Yeah. So that has been. Obviously, it was a pretty basic mistake that everyone missed, but that's been rectified, and the vehicles are now back on the road. So from my team's perspective, it is now a reliable vehicle. It's out doing the mileage, minimal interaction with Wright's and our engineering team, so it's actually doing what it says on the box now. The real benefit for us is that we've seen 250 miles on one fuel, which means that on certain duties, and for those of you who aren't bus operators, the duties during the day are all different lengths and different mileages. They're not the same. So we might have a duty in the morning which is 75 miles, but we might have another duty which starts later in the day and that runs right through till say 10 o'clock at night, and that is a 200 mile duty. Our experience on our EVs has shown trying to hit 150 miles is virtually impossible unless the perfect conditions are in play, i.e. the temperature's 13, 14 degrees, traffic's fairly light, weather's good. Any dropping down below 5 or 6 degrees, we see a 30% penalty on our EVs. So the vehicle's contracted to do a minimum 150 miles. We know in the winter it's struggling to do 100, 110. These, no problems. We've got no problems with the drivers' heat. We've got no problems with the customers' heat in the saloon. And the vehicle covers the mileage. And on certain duties, we don't need to fuel it every day. We could fuel it every other day. So there's a certain amount of redundancy built into the system again. So if the system does go down and you can't fuel for whatever reason, you've still got vehicles you can operate at some of your mileage at least. So we've kind of touched on those issues. Electric vehicles, we're constantly changing them on the road for a variety of reasons, but mainly because we can't charge them quick enough to cover the mileage, or they don't cover the mileage. The hydrogen buses, first 2 months, we had several vehicles towed in for teething faults and whatever, but since we've gone through those, it's dropped off to nothing. I'm probably recovering 4 EVs a day in at the other garages because there's just not enough charge room to complete the route, and there's nowhere for us to put a top-up charge. So again, shorter routes under 100 miles, EVs are perfect if you can charge quick enough. Right, before we get into this, there's nobody from Neil here, is there? No, okay. Right, so I can talk about I'll talk to you all frankly about the hydrogen fueling station. It's been a disaster. It's been a disaster. With COVID and everything else, it was delayed coming in and customs issues getting equipment. So those are kind of normal run-of-the-mill things, but a lot of the sensors on it weren't set up properly. They weren't talking to the vehicles correctly. The safety systems are really efficient, I can tell you that. They are extremely efficient because if they pick a sniff of anything up, it shuts the station down completely. And when it shuts it down completely, we've not got control over it. We can't go in and turn it back on. We have to wait for either their on-site engineer to come in when he feels like it, or someone has to fly over from Denmark to come and press a button and reset it type thing. It's that kind of relationship. So we don't own the fuel station. It's contracted to TfL and to Nel Hydrogen, and between the two of them there is a distinct difference in opinion of what service should be. The issues with the cooling at the beginning caused so many problems with trying to fuel the vehicles. We're having 5 or 6, 7, 8 attempts to fuel a vehicle overnight, which added to time, which meant then we were paying the cleaners overtime to stay behind and fuel the vehicles. And from then on, we've had issues with pipe fittings not sealing properly. And every time something like this done, the detection system picks up there's a problem or there's a drop in pressure and just shuts itself down, which I'm thankful for, because you want it to do that. So we know that part of the system is extremely good. It's just the rest of it doesn't actually quite live up to what we're expecting at the moment. So the station at the moment is closed down. So when you get there today, you won't see any vehicles fueling, because we're doing direct fueling from the tankers, which you'll see parked at the front of the fueling station. The system has picked up that there is a contaminant, because it's pure hydrogen coming. It's picked up as a contaminant, and it shut itself down. Now, when they eventually got here, investigations have showed that some of the filtration system for the kit has collapsed. It actually looks like it's sucked inwards, it's collapsed internally. And that's introduced foreign matter into the pipework, so the system shut itself down. Was expected to be done a week ago, then was expected to be done on the 17th. And they might be there today working on it when we get there.
We're just waiting for the quality test report to come back, so it's been repaired, just waiting for the quality report.
Okay, well, if you want to speak to Martin about the fueling station, feel free to later. But yeah, so it's been a problem. I was trying to keep my language under control there. It's been a problem, and it's the real stumbling block for us in terms of getting the efficiencies that we need to prove that it works properly. But I'm sure we'll get there one way or the other in the end. So for us, challenges. Guys have already mentioned price of the vehicles. So I operate diesels, hybrids, electrics and hydrogen. So I just see a purchase price like that. I don't see anything going like that. I see a purchase price like that. Everything is an incremental increase on the type of vehicle before. And it's always got 6 figures on it. Yeah. So this is the thing. We've got to push. We have to push the vehicles that are coming through. We've got to push to sell them, to reduce the production cost, to reduce the price. And we're at the point where, I mean, London's been doing it for 20 odd years now, and it's gone from 1.2 million down to a figure which hasn't come down as far as you'd expect it to have done. So capital costs, expensive. Within the life of the vehicle, fuel cell refurb needs to be pushed out. In London, we operate 7-year cycles. We need all of the vehicles that are manufactured for us to meet those time criteria as a minimum for us to be able to say, for every contract that we run, at 7 years, we know we've covered off everything in that first life cycle, and then the refurb of the vehicle and the systems takes part at end of year 7 to give us the next life. That's what we want in London. Whether that's what everyone else wants around the country, I don't know, but bearing in mind so many buses from London go out into the regions, I'd have thought they want the same. Parity to EV, that's what we're talking about. I need the price of a EV and hydrogen bus to be the same, because that will be the point where they're never going to fly off the shelf, but they're going to get to the market, which is what we want. Public perception of hydrogen safety, we've already kind of touched on that as well. People say hydrogen, they go, oh. I think they just have pictures of hydrogen and, what it was, not the Hindenburg, the airship that goes up in flames, like that kind of scenario. And you find that the reports of the fire at the hydrogen station, when the hydrogen station went bang, there's no reports of all the diesel and fuel pump fires that are all around the world. It's just because it's a topic at this time, and in normal circumstances, you wouldn't even raise a line in the press. Planning and approvals. For us, we had to work with the local authority to get the planning permission, and that's why I've already touched on where we chose the station, why we chose the area, because our view was it would have the minimum disruption to anything. And when you'll see, we're next to the A40, so it's a busy road. But for them, it was safer having it there. It made it a lot easier for us to get the planning permission. Limited options for fuel and equipment. We've already touched on what we think of our equipment supplier. The guys have already spoken about the fuel, how they're gradually starting to crank up the production. And it's that. It's the same as anything. It's production. Mass production brings reduction in price of everything. And that's what we're looking for. Safety. This is interesting. So when you get to the site, we'll take you through the modifications that we did to the workshop. For us as a bus operator, I want any new technology that we bring in to be able to go into any of my workshops, be worked on by anybody who's qualified next to any other type of vehicle. So I want a workshop where I can have diesel, hybrid, electric and hydrogen all next to each other being worked on in a safe manner without spending millions as TfL did on the first hydrogen workshop at First Bus and TfL at Tower Transit. So this workshop you go into, you'll see that there'll be diesels, hybrids and hydrogens all being worked on next to each other with some minor changes to the workshop. Expensive in my view, but not expensive in the view of big corporations. So, and we feel that we've come to a happy medium of safety for the staff, safety of the premises and maintainability of the vehicles. Because if we had to go and spend, if you had to go and spend £1 million modifying your workshop, it makes most of these things, most operators haven't got workshops that you can put in 20 or 30 vehicles time. They've got 4 or 5, 6 bays. If it's going to cost you £1 million to modify a building for 6 bays, why would you do it? So our target in this has always been operate the buses the same as you operate our diesels, maintain them in the same premises as we maintain our diesels, with a level of enhanced training and some minor adjustments to the building. So when you get there, you'll see that they are, in our opinion, fairly minor adjustments to the building. When I went to Aberdeen, there was nothing in Aberdeen because the workshop area was one bay, wasn't it? One bay in a massive workshop with a massive roof space. So if there was a leakage of hydrogen, the likelihood is you get 1 or 2 mil of hydrogen across the whole of the roof and it would gradually just dissipate. With us, we've put a full stair system in there to push it out as quick as possible because it's a smaller building. So the last point I'd like to make, going back to David's comments, is infrastructure. So I've been quoted £4 million to bring electricity into one of my sites. And we built a complete hydrogen fuel station for significantly less than that. And then I don't have to buy chargers. I don't have to pay for the civils within the garage to enable all that equipment to be fitted. So there is a real balance of, I suppose, opportunity to promote either of the technologies but in the right place. So I personally believe, since I was at technical college, I've always believed that the hydrogen is going to be the answer to our fueling issues. 45 years ago when I was at college. It's taken that time now for me to actually see it coming into operation, and I just feel if we don't seize the chance at this present time and build the momentum, it's just going to peter off again because the electric vehicle lobby is so loud now. And this technology can be a European and American technology. It doesn't have to come from China. This is something that we could drive the agenda on rather than the agenda being driven by others. And this isn't nothing against China, it's just about having too much power, too much production, too much control of things from one centre. So I believe that hydrogen technologies is the West's opportunity to control something and grow something which is under our control. That's a personal view, it's nothing to do with my company, that's my personal view. But we see the value of hydrogen, certainly in my operations in Australia and beyond, where we're doing 600, 700 kilometres a day on school buses, running out into the country and bringing guys into school. So that's me finished. So I look forward to your questions after.
Brilliant. There you have it from the horse's mouth. If I could ask the four speakers to take a chair up here, we'll start the Q&A session. Tim will be going around with a mic. If you've got a question for any of our four speakers, you might want to bring one of those chairs around. We might have a few online as well. Tim, we've got one down here already, if you want to jump off. We just state your name and where you're from, that'd be brilliant.
Hi there. Thanks for the presentations. I'm Sean Crespin. I'm the head of strategy and marketing for Hariba Group, including Myra. And my question is to Zemo, actually, around, you've mentioned policy coming and the ban of potential combustion buses, and we've heard that fuel cells and hydrogen are good for high utilisation and long range applications. So what is the plan for coaches? That.
Yeah, fair question. The plan for coaches is one that's certainly on the minds of ourselves for the last few years, as well as creeping into DFT's thinking more and more. Certainly, I think National Express might be in the room, who've obviously got their thoughts on it. I think we've already got some electric coaches in operation. We would expect to see a few more trials coming through. Certainly in Scotland, they're supporting coaches more and more through their Zero Emission Bus funding. We don't know the specific answer yet. I think for some, hydrogen is the clear and obvious answer for coaches. But certainly the challenge you have with coaches is getting enough energy storage on the vehicles, like we've seen with the buses, to do long speed and high speed as well. But I don't know if Tom, you want to touch on anything of Wright's looking at coaches at all?
Yeah, I mean, I think your point there is just the fact that you're looking at a vehicle on a long journey, which obviously with a coach, if you think about coach operators in the sense that there could be an intercontinental aspect, you're not necessarily staying in the country, so you've then got a high luggage load. And obviously if you've got batteries within a bus, you're invading into that luggage load. So we are very much of the opinion that there will be hydrogen coaches out there in the foreseeable future, and I mean, there's no doubt that Wrights will look at that in due course. We're just pretty busy doing other things at the moment.
Brilliant.
Thanks.
Any other questions from the floor? I'll start one off. Ian, what have you been most pleased about? We have got one. Sorry. Go
on. Chris Ashley from the Road Haulage Association, and just to explain, we've just taken on our coach membership. So just a quick follow-up, because I take your point that hydrogen may have a role for coaches, but then that begs the question of infrastructure and how you refuel coaches, en route. So just any thoughts on that in terms of overcoming that infrastructure challenge?
I think it's been touched on by both in the Zemo presentation and our presentation, the fact that you're right, that one of the biggest stumbling blocks at the moment is the infrastructure, but there is, without a doubt, there are plans in place to increase that. This is not a solution that's going to happen tomorrow, but over the next 5 or 10 years' time, and these vehicles will take time to get into the marketplace, then that kind of barrier should diminish, and you'll see far more, hydrogen vehicles doing long haul and being able to move, across the continent as well. As much as it was commented there, I'm sure the Central Europe right now are very much looking at their energy security, and where it's coming from, and hydrogen is very much a part of that, particularly in Germany and in Austria. And the idea of a coach leaving Manchester and going to the Alps and being able to fuel at known places along the way is perfectly feasible. It just needs, the infrastructure needs to be put in place.
If I could just add to that as well, I'm aware of modular designs that are operating, which take up the same footprint as a container. So from an operator's perspective, to have one of those dropped into their yard as a fueling solution, that's operational and functioning in Italy at the moment, I'm aware of, in Germany. So and that's something that as a group we're also in discussions and looking at.
If I could just make a quick comment on that. I mean, buses are very good as a starting point for fuel cell vehicles, because they're a back to base vehicle, and if you take like the haulage, there are some back to base operations. So the same kind of setup that you've got here works. But then you've got your base-to-base type operation, which again, that could work as well. And then you've got your kind of off it goes and doesn't come back for a week type operation, which is the more tough one to crack. There is like the European sort of 10T network, and there's sort of networks coming where you'll have corridors of fueling, so the planning is in place, but it has to happen. It's one thing having planning, but it has to happen. And you often hear about the issue of I hate the phrase, but the sort of chicken and egg kind of situation. If you put the fuel in there, but you haven't got the offtake for it, it's not good. But if you got the vehicles and no fuel in, it's not good. So it has to grow together. But in my personal opinion, I think it will.
Brilliant, thank you. Okay, can I just add to that? If you look at the work that's going on in the hydrogen project up north, where the hydrogen is going to be piped into people's houses to heat, over the years you've seen those massive, the old gas storage units disappear and underground pressurised compressed systems installed. And I actually think if the household side of hydrogen picks up, it will make it a lot easier to bring in like hydrogen bunkering, like you do with diesel at the moment. It will be a lot easier to pipe hydrogen to stations and make it a lot cheaper, in my opinion, to set up hydrogen fueling network throughout the UK. Thank you.
Hello, so I'm Andy Enderworth from Ricardo. Just a quick pitch. We were pleased to have our fuel cell repowered bus driving for the first time yesterday, so we're making progress. A question to Ian. Lots of people that I've spoken to think fuel cell buses are more likely to be useful outside of London. From your perspective, do you see, you're obviously operating it in London, but the feedback we get is BEV fulfills most of the needs. Do you see it as a significant opportunity inside London, or do you see it more greatly outside of London? And in what type of regions?
Okay, well, I think I'll go back to my original comment that there's got to be a place for fully electric, and there's going to be a place for hydrogen electric, or it might be some other form of power electric in the future. Our particular experience shows that the charging and planning of charging and the management of vehicles on the road takes a exponentially larger amount of effort than the hydrogen buses do. And we've got lots of duties in London where we're running 130, 140 miles upwards. It's still only a small percentage of the overall duties in London. But I think if I could go back to saying if the EV and hydrogen bus were the same price, then we're in a situation where some of those routes from 100 miles, duties from 100 miles upwards, would be much more viable with hydrogen as well. Australia, we're particularly interested because Australia is going to become a hydrogen exporter. And we've got vehicles in Australia that are doing 500,000 miles a year because of the intercity transport and, as I say, the major conurbations. They're going 200 miles outside of those sometimes for school trips and picking kids up and running back and forth to school. So I can see the benefits for National Express, Megabus, all those kind of intercity routes. And I also think that as the bus networks get more joined up with the work that's being done by the transport authorities at the moment, that these kind of networks are getting bigger and bigger and bigger, that the groups of operators are getting bigger and bigger. And a lot of operators will fall by the wayside with electric bus and hydrogen bus because they're just not going to be able to afford to operate. So bigger groups will probably pick up more of that work. But as the network expands, the mileage expands. And if you're going to look down at Brighton, I think some of the buses are looking at Brighton, they're running along the coast, up hills, down hills, and 16, 17 hours a day. And we know electric bus isn't going to be able to do that unless there is infrastructure along the route. And we were looking at EVs, we were looking at bringing our own opportunity charging platforms into our routes in London. But to do that, you've got TfL permission, local authority permission. People don't want a charger parked outside their house, and then you can't have it for sole use. So, for us, there are still, well, not still, there are very compelling reasons why hydrogen is an opportunity not to be missed.
Thank you.
Got another question there next to him.
Hi, it's Jamie Wilson from Alexander Dennis. Again, a quick plug. We've got our fuel cell EV decker on the way shortly, so watch this space. Join the ranks. Kind of quick question, probably for Ian, actually, if you don't mind. On the capex, obviously the infrastructure is really expensive, and it's even more expensive if we have to back to horses in terms of being able to look at both technology sets. There is going to be a mix of technologies. But do you see that dynamic changing over the longer haul in terms of the condition of vehicles such as battery electric vehicles as battery technology matures, and where would that sit relative to the usefulness of a battery electric vehicle and the use case for a fuel cell EV? I'd like to hear your thoughts on that, if that's okay.
Okay, so we're considering running electric and hydrogen from the same depot at the moment, which would require another power upgrade. For me, the biggest hindrance of all of this is the national grid and the 1930s type operation which is in place for applying for power. We've applied for power for a depot recently, and Alex very happily come to me and said, we're second in line for that power. And there's 16 applications in for power from that part of the network. So then we've been told the network needs to be upgraded. And when it's upgraded, we're going to be carrying a percentage of that because we want the power. But if we don't use that power, then someone else, first user charger, if someone else can take that power off of us. So of all the stuff that goes on, I started my apprenticeship in 1977, and I worked for a council. So I know the way councils worked in 1977, and it was more efficient than the national grid is in 2022. In terms of applications, what they've got to do to get power. So for me, I think if you put all your money on one horse and we say, it's all going to be hydrogen, it's all going to be electric, it's going to be very difficult. What I'd like to do is to have access to enough power to bring to a site that you've got the option of doing both, and you're not penalised for actually trying to bring that power in, because it takes away the flexibility that we require as operators. And if I wanted to bring one of my coach businesses in from outside London and bring it in to run it from one of my depots, it'd have to be electric or it'd have to be hydrogen. I wouldn't have the choice of moving both. So I think that flexibility in infrastructure is going to be very important. I'm not too sure that battery technology in the short term is going to advance as much as everyone's telling us it is. I'm a bit of a pessimist where that's concerned. And I know I don't need that with hydrogen buses because they already do. It says they'll crack that mileage. So. And the one thing that worries me about batteries is where the minerals are coming from. And I'll go back to China again, is that they've got a stranglehold on some of the rare elements that we need. And everyone's just presuming we can just carry on producing billions of batteries every year and the price of batteries is going to come down. I'm not too sure. Based on what's going on at the moment, it's just, if you look at what's going on with Germany and Russia, why wouldn't it happen with Europe and China? So I'd like to keep the batteries as small as possible, as efficient as possible, and look at another more efficient way of putting electricity into those batteries to drive, which is roughly where hydrogen sits, I would say. Not sure if I answered your question at all.
Brilliant, thanks. Yeah, I'm going to take a few questions from online. In terms of the deliveries of hydrogen, am I right in saying it's delivered as compressed? How often do you get deliveries in, and do you have any views, and open it to the panel, on liquid hydrogen and liquid hydrogen refueling?
Yeah, so ours is delivered in a liquefied form, then it's taken through a mechanism and obviously reduces it and brings it back out as a gas. We've been quite lucky because of the unreliability of the fueling station that Rise have worked with us to try and make sure that the gas arrives when we need it. But if we were running to the schedule when every vehicle was running, there's a very specific delivery plan. So basically we have a trailer in the bay which is full, and as that runs down there's another trailer next to it. They can switch the hydrogen over, and then they come and swap the empty one for a full one. So it's a very, very simple operation. Logistics-wise, RISE have to tie up with the hydrogen supply from up north and try and manage those deliveries based on our kind of not very regular scheduling because of what's occurred with the vehicles being out of operation and the hydrogen stations being out of operation. So in reality, I would presume as that went on, that would just move the same as way with our diesels. Our diesel is managed by a diesel delivery company. They monitor our tanks and they know we set a limit which we must have on site all the time, and they just manage that remotely, and I would anticipate that being exactly the same with the hydrogen delivery.
Brilliant. Roughly, with the 22 vehicles you've got, roughly how much hydrogen are you using a day or a week?
I'm trying to think how many I've had. I think at the peak we were getting, so when we did have all 20 vehicles on the road, I think we were getting delivery every other day at the peak. If not every 3 days, every 2 days. The anticipation is that there's a limit on the station where we know we could go to delivery every day if we put another, I think it's another 17 vehicles in there or something like that for a full tanker.
Fantastic. Anyone else want to touch on liquid hydrogen refuelling at all? Or? No. All good. In terms of training for drivers, Ian, have you had to do lots of training and?
Funny enough, that's why I wasn't here at 9 o'clock this morning, because I was talking with our health and safety manager about the training that was put in place, and then the next stage is the emergency training that I wanted to put in place. So working on our Zero risk assessments, there's 2 areas that we cover, which is workshop and depot, and the second is bus and operations on the road. So we covered off the original items in terms of safe evacuation of a vehicle, what the warning systems mean, how to identify a hydrogen fire, because obviously no flames. But we're now working on the next stage of that with some videos and booklets that we'll put together for our drivers. But in terms of the driver training, 3 hours, something 2.5 hours, 3 hours a driver. And I will say the drivers love the vehicles. They're extremely comfortable, extremely quiet, and they like driving them. So unfortunately, the issues that we've had with the fueling process have kind of impinged on that bit. But it's an ongoing thing. I've asked my health and safety manager to speak to RITES because I want to go through the next phase of the warning systems on the vehicles so they understand a bit more about the specific warning systems, what they relate specifically to. Because at the moment, it's just based on if a warning light comes on, you do X, Y, Z. If this warning light comes on, you do X, Y, Z. But as we're starting to operate the vehicles, we'll get a better understanding of what the other little anomalies are when a light comes on and whether you should stop the vehicle or not. And in our traditional diesel and hybrid operation, we have what we call a stop-go list. So the radio controllers or the people in the control room, if a light comes on, they can relate to what their light is, and there's a message alongside it which says, stop what you're doing, get an engineer out, or actually the vehicle can carry on duty till it gets to a safe point. So we want to reach the same point with the hydrogen vehicles as well.
Brilliant, thank you. Got a question for you, Ben, about the Fuse turnkey solution. Is there any upfront capital outlay required for your solution?
The short answer is no. It doesn't have to have any capital outlay with the funding model that we've got. On the SPV model, there's an option for an equity investment to be made. So with regards to talking to PTAs, where there is sort of some form of funding coming in, the funding doesn't necessarily have to go direct into, for example, the Zebra scheme against the CapEx. That funding can be used to go in as an equity investment within the SPV structure. So, but in short answer, no, there doesn't have to be any equity or any cash money or money's going down as a deposit against the vehicles.
Fantastic, thank you. David, I wanted to ask you about refurbishment of fuel cells and lifetimes. What sort of lifetime are you looking at in terms of refurbishment?
Well, when we're looking at, unfortunately, fuel cells are done in hours, so which doesn't necessarily relate to the operating hours of the bus on the road. But with fuel cells that we operated from Tower Transit, we got up to over 35,000 hours on the fuel cell. Relating that to a bus operation of a 15-year bus, you're probably talking about one refurb in that time, potentially two, but one at the moment. So the longevity of the fuel cell is sort of 5 to 7 years. I would say that's what we're looking at the moment.
Okay.
And
And with regard to that, from the TCO model, we are including the cost of a refurb within the calculation. So when we look at a TCO model over 15 years, we have taken that into account. So there's no sort of hidden costs or surprises coming further on down the line. That's been factored in.
And is that refurb process a complicated process? Is it a long process? Do you have to swap out the fuel cell for a new one, or would you always look to replace an existing one with the refurb?
So there's potentially many ways to do it. So you can take the whole fuel cell module out, take the fuel cell stack out, get that swapped, and then get back on the road, or you could send the whole thing off and come back. It depends. It depends how you want to do it. If you're gonna ask me the exact time that it takes to do the actual refurb, I can't answer that, but I'll go and find out.
For next time. Brilliant. A few questions. Go on, Martin.
Yeah, maybe it's a question for Ben, maybe Tom. I think a couple of guys picked up on it, and the scalability potential of hydrogen is much more significant than sort of battery electric, which is quite linear. One battery bus, one charger, and so on and so forth. So 100 battery electric buses, 100 chargers. From a TCO perspective, what do you think sort of the minimum sort of acceptable quantity of buses will be required to sort of get a project going? Because I'd imagine most people like to dip their toes in the water before diving in, so would like to do one bus, but that works great for battery electric, but it's quite challenging for hydrogen. And at what point do you really get to really best value? Is it 100 buses, 500 if you want it to be really brave, and sort of what is the difference between the two in the potential?
So from a impact of scale, so the first thing is the challenge has been set within Wrightbus to really look at the capex point. Ian alluded to the fact that if we can get parity on capex on day one with hydrogen, that's where we'd like to get to as a first step. The impact to scale does exist there is a definitive number. I've sat with the guys at Wrights. I think that may be changing somewhat in recent times, but circa sort of about 1,000 vehicles means at that point, at that capex point, is starting to come down similar to where we would be with battery electric. But I think it's not just the capex opportunity. When you look at the TCO, it's the impact on the fuel requirements at that point. So at the moment, where sort of pre-COVID we'd be at £6 a kilo, £6.50 a kilo, like everything else, it all went north. And at the moment, parity exists around sort of £7.50 a kilo to get to parity with diesel. That price point will come down significantly as soon as scalability is applied, and not just buses are on the road, trucks are on the road, and aviation's tapping in and taking resources out. So I think there are many levers that need to be manipulated or pulled, so to speak, to get to below parity. Because the challenge is not to get to parity with diesel, it's to get to where parity exists with electric at the moment.
So if an operator is interested in dipping their toe into the water, what would you sort of recommend the minimum number of buses to sort of get a project has a TCO which could be acceptable given where we are?
It's difficult to put an exact number on. I think sort of 1,000 vehicle sort of number seems to be where the figures are indicating at the moment, and that doesn't have to be with a single operator. The SPV funding model is set up on what we call a hopper approach. So in that regards, we can start to combine different projects together. So if you have to go and deal with 3, 4, 5 operators to get to 750, 800 vehicle deal at that point, I think you'd probably get to that point then.
Brilliant. I think we've got one more from the audience, a couple more.
Hi, Livia Higgins from the Department for Transport. It was my team that oversaw the creation of the Zebra scheme, which we referred to, and obviously recently announced a further £200 million of funding to be allocated through that. I think The question I have is obviously from a typically sort of public sector side, which is that obviously through the process we worked with a range of local authorities to develop their proposals of either battery electric or hydrogen, and it's fair to say that the vast majority went down the battery electric route. In terms of a sort of reflection piece for us, and I'd be really interested in all four speakers' views on this, if you were trying to land with public sector organisations that are starting to think about their shift towards zero-emission vehicles more generally on a hydrogen or a battery electric point, what would be the kind of key messages you would want to sort of land on a hydrogen perspective, noting that the sort of long listing process of areas trying to consider what worked for them was often informed by knowledge of existing hydrogen production or if they had a burgeoning hydrogen economy and things such as that. But for a lot of areas, hydrogen is a sort of new kid on the block. And trying to understand sort of the opportunities for that can be complicated for local authorities. So public sector organisations, what would be your message to them when starting to think about zero-emission vehicles?
Yeah, Ian's just saying in my ear, and that's exactly what it is. It's having the flexibility across your vehicle fleet. You know, if you're local authorities looking at it, the public sector side, you know, the infrastructure cost for electric vehicles is very high from the outlay, and actually be able to move your fleet around and do different routes at different times, then hydrogen lends itself to that. It's for us as manufacturers of hydrogen vehicles that are out there to also pass that message on and demonstrate it, you know, and we are doing that. As Ian has alluded to, the battery electric lobby is very loud, and we need to raise our voices a lot more on that front because the technology works, as has been demonstrated. You know, it also is far better for the UK in general in a sense of energy security. So we just have to continue to work hard and pass the message on as much as possible, because we can demonstrate how it operates and how flexible the product is, then the uptake will increase.
I'd just like to add to that. As I've already let you know, I did my apprenticeship at a local authority. The flexibility we're talking about there is you've got street lighting vehicles, you've got refuse vehicles, you've got road sweepers, you've got gully suckers, you've got Meals on Wheels vans, you've got all kinds of options, transport options that are fit within the local authority envelope. Electric can't do all those. You know, there are some electric dust carts out there, appreciate that, but street lighting vehicles, you know, you've got hoists, you've got lifts, you've got all kinds of kit, very similar to what was described on the industrial equipment that's been used on building sites and similar. So if you're going to create equipment that you're going to put batteries on, which is going to increase the weight of the vehicle, which is going to decrease the operational range of the vehicle in terms of not the mileage, but the things that it can do, it just makes sense to me that a enlightened local authority will be looking at transport for bus routes, but also be looking internally at the equipment it needs to run to do the similar operation. So I've been working, I did some work with the London Fire Brigade for their tenders and their pumps, and the penny dropped to them that if they were stuck at a fire for 7 hours and they've got something pumping for 7 hours, electric vehicles not going to do it. So some people will naturally be forced to look in other areas. I just think that there needs to be a more of a joined-up conversation with lots of different parties, because as I said, the EV market is very loud, and they've got all the headlines. But in the background, if you look at the plant and equipment out there, you realise the limitations of electricity for everything.
The first thing is the authorities come and talk to me, come and talk to us, you know, because you said a lot of them think it's new technology. In my view, it isn't, because I've been doing this stuff for 10 years. I've been running buses. TfL have been running fuel cell buses before they've been running battery electric buses. So it's not new technology. It's there. The other thing you find as well when people don't they always think fuel cell is complicated, and it kind of seems it on the outside, but actually it's not as complicated as you think. And as already been said today, there's more to running a fuel cell bus. It's actually running a bus we've got to think about, not run it and then look at what technology works for that bus. And in some cases, battery electric's fine. I'm not against battery electric in that sense. And the other thing is, a lot of people, if you sit around a sit around a table, they think that running a fuel cell, running a battery electric bus is like the same thing as these things that we've all got. You just plug it in, take it out, and it works. But charging that up is a hell of a lot different to charging buses up and running buses on routes. But the perception is that it's like a phone and it's easy to do. So I think there just needs to be more awareness. I mean, the ZEBRA funding has been great, and the funding for the fuel cell buses has been great from the last ZEBRA funding. For me personally, I'd like to see an awful lot more funding going to the fuel cell buses, and the thing is that the authorities have to apply for it at the end of the day. So you know, it's not necessarily the funding's fault, but with some funding as well, I'm not saying ZEBRA funding at all, but I've seen other funding streams where they say, or tenders or whatever, and they say, oh, zero emission, and then it's all spoken about as if it's battery electric, and not just neutral. And all we need to see is just neutral, you know, and people choose what's best for their situation. That's all I ask anyway.
Brilliant, thank you. I think we've got time for one more question at the back there.
Thanks, Andy Eastlake from Zemo. A couple of questions, if I may. Firstly, thank you very much. Some really good information, and the reason I like coming to these things is I always learn something. So, one of the challenges on the battery electrics, and we're still kind of finding our way, is how long the batteries last. Thank you for your commentary on the fuel cell, but obviously within the fuel cell bus, you've also got a battery which is being exercised in a different way, and you've got the tanks. And there's been various commentaries around how long do the tanks last, or when do they have to be refurbished. It was just a quick summary of what the other considerations need to be, and does that sit in with a sort of natural 7-year refurbishment cycle for the vehicle, just on the battery and the tanks for those buses? That was the first one, really. The second piece of the question, because I'm very interested in the commentary around coaches, absolutely right. You know, the challenges of the longer haul and that sort of thing. One of the things we're seeing in the truck side is the opportunity for fuel cell, of course, in trucks. But it appears that one of the restrictions is actually the size of the fuel cells, getting enough power on board. Getting enough battery on board is a range problem, but getting enough power in the fuel cell. So whether there was any commentary about where fuel cell power is going. At the moment, you're talking 100 kilowatts in your current sort of production spec. Do we see that getting up to the 200, 250, 300 kilowatts that we might need in some of those higher speed, longer haul operations, possibly coach and certainly heavy goods? So those two sort of elements, ideally. Sorry, more than one question, Dan.
Yeah, so taking the second question first, yes, we see the power going up. Ballard have a marine fuel cell that's 200 kilowatts at the moment. That's that you can add on in 200 kilowatt blocks to go up to megawatts. So that is coming along. To answer the first question about battery life. Battery life on battery electric buses, excuse me, that's been a sort of big was a big debate when battery electric buses were coming in, how long they would last, and I'll let Ian answer the question. The fuel on the hybrid buses on the fuel cell, the batteries are run in a different way, so they're taking up the peak power of the bus operation rather than filling up and then draining down, filling up, draining down. So there's a different cycle for the batteries. And as far as the tank's concerned, the tanks normally, I don't know how long the life on your tank's, 25 years, 15 is it? Yeah, 15. Yeah, but that's the lifetime of the bus, certainly in the UK. So the tank's not a problem. You need to do some sort of visual inspection and that on route, but the tank should last the life of the bus. And I wouldn't expect the batteries to be used so as severely as on a battery electric bus, but I don't know, maybe Ian can say operationally a bit more.
So operationally, for our battery vehicles, I think what you've got to bear in mind is when you see the state of charge on an electric vehicle, when it goes to zero, it's not going to zero. It's going to the level that the manufacturer's window has been set at. So when we bought our first Alexander Dennis's, they had a 70% power window. So that meant that from 100 to 70 was 100% on your state of charge, effectively. And that's how the life of the battery is extended. They don't let you deep cycle it. It's kept at the higher end of the power with a minimum amount of discharge, and that's where you get your warranties from. The NRM, the new Routemaster, when that came out, that had a different setup, and they used as much of the electric power as possible. So that they had a SOC window, I think, of about 70% of the total charge, where ADL was 30%. And those batteries were worn out after 2.5, 3 years. The ADL ones lasted for 5, 6 years, but because they were using much less of the power in the battery pack. So our standard warranty requirement on our tenders is a minimum of 7 years now. And some suppliers are very bullish, saying their batteries will last 10 years. And others are saying 7 years as long as you stick to this, this and this. So there is that kind of a range of commitment from the manufacturers about what the battery might achieve. So we've been told you can get a battery which will last 20 years, but you'd be charged, you'd only be using X amount of power per day, and you'd be charging it more frequently. And the problem is, the more you charge it, the more you affect the life of the battery as well. So there's lots of things to take in consideration. But it would be interesting for me to see Arctics, 40-ton Arctics on battery, to see how far they got on that and how long they lasted.
I mean, from a peace of mind point of view, Wright with their batteries are able to offer sort of extended warranties as well, up to 15 years on the batteries. And the fuel cell, is it 1 million Ks or 10 years? We can. Yeah. So again, when I talk about moving levers from a TCO perspective, that's one of the things we can do. We can offer an enhanced, longer warranty period, and that enables obviously the R&M or the parts assurance cost to become lower.
Brilliant. Okay, we'll take one more question. Why not? And then we'll draw it to an end.
Hi, I'm Mungo Fawcett from Zenobi. Just asking about the way the funding is set up at the minute, and being hydrogen versus battery electric in a lot of cases, and given the scale of deals that Ben's talking about for parity for hydrogen, it's always going to be quite hard to justify going hydrogen against battery electric if it's a competitive process with them against each other. Would it make more sense to split funding streams for hydrogen and battery electric when there's a limited budget for funding?
I can obviously pass comment. In terms of, obviously in Scotland, they do offer more funding up for hydrogen vehicles and hydrogen infrastructure. I think it's 85% the cost difference for the infrastructure, and they do offer, I think, up to 230k per vehicle for hydrogen fuel cell versus, I think, 180 for a full-size battery electric bus. Don't know if you guys want to... Yeah. You like that? I appreciate that, yeah. I don't know if DFT wanted to comment at all on that. Probably not. No. I think it's an interesting point, and there certainly are hydrogen funding streams out there, obviously for the infrastructure side of things. So it's certainly something we can look to put forward. Obviously, we've got the various consultations out at the moment, whether it's for buses, end of diesel sales. So that's potentially something to include in our response as well to that. Go on, Ian.
Okay, so I suppose the last thing I want to say on this is there was a 1,000 bus target in London for bringing the price of hybrids down. But what nobody took into account was there was more than one manufacturer manufacturing hybrid vehicles. So the point's been made, 1,000 vehicles for one manufacturer will result in them reducing their prices, but that won't result in other people reducing their prices because they're still paying the higher cost of materials that they're not getting through the bulk purchase. So don't go away from here thinking 1,000 vehicles and the prices will come down. That's 1,000 vehicles with one manufacturer.
If you buy Ballard fuel cells though, David will be happy.
Brilliant. Okay, and on that bombshell, we'll probably bring the Q&A session to an end. If you could just give the speakers a round of applause. Hopefully some really useful information for you there. The speakers will be around for the rest of the day. The slides will be shared. There's also a recording that we will share with everyone here that you can watch on YouTube later on. We'll now go off and have a look at the buses and go and have a look at the site infrastructure. We might just scrap the coloured buttons on your badges. If you're really, really keen to go on the first session, we can get 30 on the bus. So if you follow Alex and Ian to the bus, the first 30 on, we'll get to go for the first session. And the rest can have a look around the second bus. There's tea and coffee and snacks again, so feel free to top up. And then lunch will be served from 12:30. Thank you very much.
David, good to see you, mate.